Well, colloids. Colloids, also called colloidal dispersions, are mixtures that are a little different than solutions. So it's a mixture in which the dispersed substance, which is equivalent to the solute, is finely divided in the dispersing medium. What's different about this from a solution is that the particles are larger than solute particles in a solution. They are small enough to remain suspended in the liquid, but they're large enough that they can actually reflect light. And so typically a colloidal suspension is going to be somewhat cloudy in appearance, unlike a solution that you can see straight through because the particles are so small. So these particles are typically like 1 nanometer to 1,000 nanometers in diameter. And so the wavelength of light, visible light, falls within that range, and so these are going to affect light passing through. If we look at these particles under a microscope, we can actually see them because they're much larger than molecules. Colloidal particles have a distinctive jittery motion. It's called Brownian motion. And this motion is caused by collisions between the solute or the colloidal particles and the water molecules. And so this is the author's attempt at illustrating the path that this particle might take. It's just going to be jiggly all over the place. It's a bit like a beach ball at a graduation or a party or something thrown out into the crowd, right? And people hit it and it just like goes who knows where, right? There's no pattern to its movement. Why is it moving? Because people are hitting it. Here, we don't see the particles that are hitting this colloidal particle because they're too small, they're water molecules, but we see the movement of the particle. So I've got a video of this. There we go. So these are pollen grains. See them wiggling? They look like they're alive, but they're not. They're like beach balls getting hit by water molecules. It's really short. And what happens to the legs?
When you're watching this movie, you might notice that there are little ripples on the surface. And those ripples are actually real. What you see there are.
Yeah, that's a great video, but it doesn't relate to today's lecture. So, any questions about Brownian motion? So, soap and water is going to form a colloidal solution. The soap molecules are forming micelles, which are the colloidal particles. They're large enough to scatter light. So we looked at this a little bit earlier. We talked about how soap works. So here we have a soap molecule. It's polar at one end and nonpolar at the other end. And so you put a bunch of these in water, and the nonpolar tails are going to be attracted to each other. So they're going to gather together, and the polar heads are going to be on the outside. And so they're going to form a micelle, a sphere of molecules, kind of like, you know, the settlers circling the wagons, but in 3 dimensions. The soap is able to remove grease and oils because the grease and the oil will dissolve in the interior of the micelle, but the outside, being polar, can move freely through the water. The micelles stay separate from each other due to electrostatic repulsions. So instead of like an oil, which would just gather together and form one big glob or layer, these individual micelles are going to be repelled by each other and stay in suspension. Macromolecules like proteins also form colloids. So if you look at milk, you know, milk is white, right? You can't see through it. And yet there's no precipitate, right? So why is it white? protein molecules and other macromolecules are suspended in this colloid suspension, but they're large enough that they can the thing they do with light. Yeah, I don't know where that word went. Scatter. There it is. It's right there. Scatter. There's large enough to scatter light. We're almost done here. It's a good thing. There are a lot of different colloidal dispersions that we run into in regular life. You can have a liquid, the dispersing substance. So this is the part that's like the solute dispersed in air, and that's called an aerosol. So fog is an example of this. You can't see through fog because the tiny water droplets are large enough to scatter light. You take an aerosol can and you spray it. What's coming out is an aerosol. It's liquid particles suspended in gas. You can also have a solid aerosol, and that would be something like smoke. Smoke is small pieces of ash dispersed in air. A foam is a gas and a liquid, whipped cream. Thanksgiving, right? Pumpkin pie. Whipped cream is a liquid, the butter fat, with air dispersed into it. An emulsion is a liquid in a liquid. An example of that is milk. You get the fat globules and the protein molecules dispersed in the liquid. And then you can also have a solid emulsion. So opal, these are gems. People make rings out with them and stuff. That's actually water dispersed in silica glass. So it's a liquid dispersed in a solid. The Tyndall effect is seen with colloidal dispersions. So if we shine a bright light through these two liquids, this first one, without the light shining through it, it looks clear, right? We can see through it. It looks pretty clear. It looks like a solution. But when we shine a strong beam of light through it, we can actually see the beam of light as it's going through. And that's called the Tyndall effect. And what's happening here is the particles in the suspension are large enough to scatter light. They're just not so many of them that they scatter all the light, so we can see through it. This is the solution where the particles are too small to scatter light, and the light goes through and we can't see it at all. Here's an example of dust in the air. And so the sun is streaming in through these windows, and we see these sunbeams, right? You may have noticed these as a child. You're like, oh, wow, look at that. I can see the sun coming in. What is it? Well, it's because your house is dusty, right? There's dust in the air. And so as the sun shines through it, those dust particles are large enough to scatter the light. This is the same sort of thing that happens with smog, right? The smog particles are large enough that they can scatter light.